X is a discrete random variable. X is a discrete random variable. So what does that mean? X can take only countably finite or countably infinite values. Like this. Let's take the case where X is taking countably infinite. Okay, because the other one is a subset. Then Y is actually g of x, a function of the random variable. What would be the nature of y? Y will be also a random variable. We are assuming it, and y belongs to g of x2. Sorry, here should be small letters, etc. This here there's a slight abuse of notation. Um, because normally when we write random variables, we write it in the increasing order, like 1, 2, 3, etc. So here it's not necessary that uh, these g of x1, g of x2 are in increasing order, or and also it's not necessary that they are distinct. Ultimately, it's a set, so we have to arrange it in some manner, and that is also not a big requirement, but we normally does that. And what else do we have? We only have distinct elements in a set. There's no point in repeating an element twice in a set. So yeah, there's a slight abuse of notation. Then what is interesting for us is to find the PMF. PMF of I, right? Earlier we, for continuous random variables, we found out the distribution function. Here we are more interested in the PMF because it is something which we can obtain ultimately. In a continuous way, domain, distribution functions are something which we can obtain because the probability at a particular point doesn't make much sense. Okay, so if you're going to find the mass function of the new random variable y, by definition, that is equal to p of y equal to y, right? So what is y here? That is g of x equal to y, right? So early what the advantage we had was it was a function, so we can use the concept of inverse of a function here. But here we have to contemplate it more sensibly, right? So what does this mean? The g of x is equal to y. It means x belongs to set of all x such that g of xi belongs to y, right? So what does it mean? We have to add, ultimately we have to add fx of, we have to add fx of xi for all i's such that g of xi is equal to y. Okay. To make this more clear, let's take few examples. Let's use another color for this. Okay, let's take an example. Let x belong to the set. Let x be a random variable which can take the values 1, 2, 3, etc. up to n, with fx of k is 1 by n. What is this? This is an equally likely assumption and it's uniformly distributed. right? And y is equal to the same affine transformation we had earlier. Then the question is then how to find fy of y, right? Now we know y is equal to ax plus b, right? So if x is taking values 1, 2, 3, etc. up to n, what all values can y take? X belongs to y belongs to a plus b, 2a plus b, 3a plus b, etc. na plus b, right? So to get PMF of y, fy y. So the n term in this equation is, so how do we specify the mass function of a discrete variable? We normally use another dummy variable for this. We normally don't use x as it is. Okay, so we have y is equal to this can be written as b plus ka is equal to fx of k is equal to 1 by a. 1 less than or equal to k less than or equal to n. I hope this is clear. Or do we want more clarity on this? Right. How do we, okay, how do we get more clarity on this? What is the PMF of fy of y? This is actually same as probability. Probability of y equal to y. I hope there is no doubt in that. That is probability. What is y? Ax plus b is equal to y. Is there an issue with it? Okay, let's see. If we are not defining it as y, normally we use k for this, right? Yeah. So what does this mean? This is sum of fx of all xi such that ax plus b is equal to k. Where does ax plus b, or we can even write this as, okay, this is probability of x is equal to k minus b by a. This is an event. What is the probability of this particular event? This is equal to 1 by n. Right? Why? Because probability of x equal to x is actually 1 by n for any event. So this is f y of k. Now let's take another example. Another example where x is geometric. Okay, let me use another color for this. So let's take the example, another example where x is geometric and y is equal to x minus 1, right? So if f of x is geometric, fx of k can be written as 1 minus p k minus 1 to p, where k is equal to 1, 2, 3, etc. Right? Now we know y is equal to x minus 1. So fy of any variable, let's take k itself. Ultimately, we are just using mass function here. It's equal to p of y is equal to y. No doubt about it. That is p of what is y? X minus 1 is equal to y. Sorry, not y. Equal to k. That is p of x is equal to 1 plus k. Am I right? So in this geometric distribution, what is f of x is 1 plus k, so that will be 1 minus p raised to, instead of k we have 1 plus k, so there's 1 plus k minus 1 into p, that is 1 minus p to k to p. K varies from, this is also important because earlier k was varying from 1, 2, 3, etc. But y is a random variable with x minus 1. So k can vary from 0, 1, 2, 3, etc. Right? And here also it is important to specify what is the variation of k here. Here k can vary from 1 less than equal to k less than equal to n. Here also it can vary from 1 less than equal to k less than equal to n. Why? Because if k equal to 1, what is the value of a? It's a plus b. Right. No, it's not. Right? It is a plus b less than or equal to k less than or equal to, yeah, a plus n. I hope this is clear now. Okay. So this is how we calculate the mass function of discrete functions. We can look at few more examples which are relevant in the coming lectures.